Assalamu alaikum. So the next part of our project is flip flops. The flip flops are basically the storage elements which store any state. Any state, maybe there are only two states. Whether it could be in the set state or whether it could be in the reset state, or it retain any one of these states. Uh, the retaining and changing of these states depends upon the clock pulses. Some could be the positive edge flip flop. It could be the negative edge, and it could be the pulse triggered flip flop. Like it changes its outputs according to its inputs when the clock pulse arrives. Here we are using and discussing about the positive edge D flip flops. Like it changes its input outputs according to its input when only the positive edge of the clock pulse arrives. uh, the when the clock pulse is high, like the positive edge has arrived. If the D is zero, uh, the input we have given to the D place of this D flip flop is zero and the clock pulse has arrived, its output would also be replicates to zero and the flip flop would be in reset state. And when the at the high clock pulse, when the D is 1, yeah, at the input its output replicates, and the output would also get 1 by making the flip flop in set state. But what happens if the clock pulse is zero? This is the main functionality of this flip flop, that it retains its state when the clock pulse is zero. Like if the clock pulse is zero and you make the changes at D, like you change it from zero to one or one to zero. But if there is no clock pulse, the output would not change. In this way, we can achieve that whether the output our output does not changes uh, when our input changes. Like our outputs are independent of our inputs, but only dependent on inputs when the clock pulse is high. Now let us discuss the BCD to 7 segment display. So first, I have tell you that what is BCD. BCD is the binary coded decimal, which is of four binary bits. The it represents the any of the decimal number into binary coded decimal number. Like it could be the binary of made up of four bits. For example, let us see from this table. Like for zero, it is represented at these four bits, and for all of the bits are zero. Here's similarly 1, 2, 3, 4 till 9. Their binary are same. Binary and BCD are same, but above 9, we have to the one of this 10 is represented separately, uh, as this one, and 0 of this 10 is represented separately as this one. uh, in this way we can say that BCD are from 0 to 9, and then it copies, and all of the bits, all of the separately the BCD, the decimal number is represented in BCD. BCD are from 0 to 9 and consist of 4 bits. Here we are using a driver for this 7 segment display. This 7 segment display is the combination of the LEDs in a specific pattern, that the combination of on LEDs and off LEDs shows us a specific number, or it could be any alphabet which can be represented in these 7 LEDs. To use this 7 segment with this decoder, we here have the limiting current limiting resistors for these LEDs to be safe, to work properly. And the 7 segment displays could be of two types. It may could be a common anode and it could be a common cathode. For common anode, you have to give the zero logic at its inputs to make the LED on, and for common cathode, you have to give the clock pulse. You have to give the high logic to make these LEDs on. Uh, If you don't want to use the 7447 driver, you can make a combinational circuit. Combinational circuit is the combination of the logic gates by which you can represent this a BCD number onto that 7 segment display. Its LEDs are separately named as A, B, C, D, E, F, G, and the circuit, the K maps are made accordingly, and we have obtained the functions. These functions have to be implemented at the output. These functions to be implemented at the it would have four inputs of BCDs and seven outputs for that driver. Otherwise, you can use that driver for the 7 segment display. Moving to our simulations, where here are the four flip flops placed, and here's the 7447 decoder. The four inputs are coming here at the pins 7, 1, 2, and 6 as the BCD numbers. ABCD, BCD binary code decimal, and these are all the other pins of this IC. And here is the seven outputs of this driver, which are correspondingly connected to this 7 segment display. For this 7 segment display, this is the common Anode 7 segment display. Like when here the logic is low, as we discussed in the previous video, that for this bubble, the pin would be active for zero logic. Uh, Similarly, in this the driver to this BCD to this 7 segment display, when the logic is low, the corresponding LED gets high. These are common anode that commonly it is given 5 volts, and separately to these LEDs the zero logic is given to operate these. Why its output is changing consistently by adding one number to it, we will discuss it later in our next video. Thank you.